This video covers Cheyney's homework for report period 1, week 7, October 2nd to October 6th. Let's look at Monday. On Monday night's homework, we're practicing comparing two unit rates, and you're set up with some nice graphic organizers. Question 1 says, an elephant can travel at a constant speed of 2.5 miles per hour, while a giraffe can travel at a constant speed of 16 miles in 12 hours. Who runs faster? Explain your reasoning. So when we look at the elephant, they actually gave us the answer. It's 2.5 miles per hour because it can go 2.5 miles in 1 hour. In the case of the giraffe, we know we're looking at 16 miles per, that's our division symbol. We're splitting up 16 miles between 12 hours. And if you went ahead and split up 16 divided by 12 in your calculator, you end up with 1.33 miles per hour. Now remember, this per hour language, and whether it's per hour, per minute, per second, means per one. It means in 1 hour, what can happen. And now you know for both animals how far they can travel in the same amount of time. So you can go ahead and write a full sentence to compare which one's moving faster. In the next part of the homework assignment, question 2, you're doing something similar. You're looking for something per something. So make sure to keep the order of your division straight. The next part of this video is going to cover Tuesday. On Tuesday night's homework, you're being asked to solve rate problems, a lot like what I just demoed on Monday's homework, but we're going to take a look at the unit price problem in question 2. Question 2 says, show your work to solve each unit price problem. Your final answers must have labels. As a reminder, unit price always means the price per one. And so I've set you up with a nice graphic organizer in part A. It says, at the market, 5 light bulbs cost $9. What is the cost per bulb? So I know that I'm splitting up $9 between 5 light bulbs. And once you divide 9 by 5, you'll get the final answer here for the cost per bulb. What's important is that if I'm looking for the cost per bulb, I am splitting up the number of bulbs. I should say I'm splitting up the cost. I'm splitting up the cost into 5 groups because I spent those $9 across 5 different light bulbs. And I want to know how much I spent on each individual bulb. So we want to be really careful that our division is moving in the correct direction. Let's take a look at 3. In question 3, you have the same shapes as you did on Monday night's homework, but we're going to use the directions to sketch a new shape. For example, in question, or I should say in row 1, we've got a rectangle with a width of 10 yards and a length of 5 yards. We know that the width of the new rectangle should be twice as wide. So if the width is 10, I know that I'm multiplying 10 times 2 for a new width of 20 yards. And the length is going to be 3 times as long. So the length was 5. 5 times 3, 15 yards. And then they want us to calculate the area of the new shape. An area we know is just length times width, which means I'm multiplying 20 times 15 for an area of 300 square yards. And remember, when we're talking about area, our units are always square units because we're thinking about how much space there is within an object. All right, let's head to Wednesday. On Wednesday night's homework, we're being given some unit rates like we practiced in class today. Let's look at 1 first. Once a commercial plane reaches the desired altitude, the pilot often travels at a cruising speed. On average, the cruising speed is 570 miles per hour. So if a plane travels at this cruising speed for 7 hours, how far does the plane travel while cruising at this speed? So our old strategy for doing this might have looked something like this: miles, hours, or maybe reversed. But we know that in 1 hour, we can go 570 miles. And so you could have counted down the table. to figure out how many miles can be traveled all the way down to 7 hours. But we can also see the pattern in the table, which is that we're multiplying the number of hours by 570 miles. We learned today in class that this makes sense because if we know the unit rate, the miles per hour, not hours, hour, and we multiply it by the number of hours, we're doing 750 miles per hour over and over again 7 times. And so the hours unit cancels out, and we end up with 570 times 7, which you might have to work out separately. I know that I do. For a total of 3,990 miles. And that's not per hour, that's in 7 hours. And I'm always going to circle that final answer. We want to be careful not to assume that we're just dividing to find the unit rate if the question already has provided that unit rate to us. And so in this case, they're not asking what's the miles per hour. They're saying this is the miles per hour. What's the distance? So we want to make sure we're reading super carefully. All right, Thursday's last, and on Thursday's homework, we've got these big comparison problems like what we did in class. It says 3 students walk to school at different paces, and their speeds are represented below. Which student walks the fastest? Show your work and write your final answer in a full sentence. So in each of these questions, we're comparing minutes to meters, okay? And so I'm going to just assume that I need to find the unit rate, which would be meters per minute. And so in this table, I can see that I've got 110 meters for 2 minutes, which gives me a meters per minute of 55. 55 meters per minute. In question, in student B says D equals 60t, and I'm going to assume that t is time and d is distance. That's totally Miss Kinez's fault. That should be written down for you. But I know that I'm multiplying 60 times the number of minutes to get the distance. And so if I travel for 1 minute, the distance is going to be 60 meters per minute. And I said the distance. I should have said the rate, the distance per minute, right? Because we're going 60 meters for 1 minute. And so the distance is 60 meters. But since the per is per 1, since there's 1 minute involved, it's meters per minute. And then we can see the meters per minute in the graph as well, because if we just look at how long is traveled in 1 minute, we can see 50 meters are traveled in 1 minute. In a graph, if there was ever a situation where you couldn't see how far was being traveled in 1 minute, you could pick any other pair. For example, 3, 150. And if you divided the number of minutes by the number of meters, 150 divided by 3, you would get the same answer, which is 50 meters per minute. And so now you have a unit rate, a rate per 1 for all of the students, and you want to write a full sentence at the bottom telling me which student runs the fastest. That's it for Thursday night's homework helper video. If you have any questions, as always, please make sure you're checking in with Miss Kinez by the end of the week.